Welcome to day 8 of Just Start Programming, the Rust programming language. So let's do a quick review on what we have covered yesterday. I think we have stopped somewhere. Yeah, here. All about managing growing projects with packages, crates, and modules. Let me just glance through just to refresh our memory. So there's this concept of packages, crates, modules, and paths. Then if we start with packages and crates, I think it was mentioned somewhere here that crate, yeah, stations say crate, they mean library crate. And they use crate interchangeably with the general programming concept of a library. Yeah, so this is how we create a new project. If we do it this way, then by default, it will create a main.rs. And there's a difference between having a binary crate and a library crate. Yeah, so if you have main.rs, that would be your binary crate. So likewise, Cargo knows that if the package directory contains lib.rs, then that would be the library crate. Modules. Defining modules to control scope and privacy. So there are a couple of keywords here that we need to take note. You have the use keyword, you have the pub keyword, and the mod keyword. Start from the crate root. When compiling a crate, the compiler first looks in the crate root file, usually the lib.rs for library crate or main.rs for binary crate. And when you declare modules, you have mod and then the module name. So there are three ways of doing this, whether inline, within curly brackets. You can do it in the file, meaning under source, you can create garden.rs. In the file, actually this is in the file directory garden, and then you have a mod.rs. So automatically, if you name it mod.rs, the parent directory would be identified as the name of the mod. And then how do we declare submodules? So this is modules, and now you have submodules. So the same thing, you have mod, but in this case, okay, if it's in the file, if you name the file explicitly like vegetables.rs, that would be under garden, yeah, or you can have a subdirectory vegetables and then mod.rs. Paths to code in modules. For example, an asparagus type in the garden vegetables module would be found crate, garden, vegetables, asparagus. Yeah, so we learned yesterday also that crate is the root. It is considered as the root. So it's like a keyword. And then you have an option to make it private or public. And one important thing to remember that to make items within a public module public, we use pub. So we need to explicitly specify pub before their declarations. Otherwise, it's going to be private. The use keyword within a scope, the use keyword creates shortcuts to items to reduce repetition of long paths in any scope that can refer to. So instead of having it quite long like this, you can create a shortcut use. And from then on, you only need to write asparagus to make use of that type in the scope. Okay, so here's an example of crates directory. So name backyard. We have seen this before. You have source, you have main. In this case, garden is a module having vegetable modules inside it. The implementation of the garden module is here. Implementation of the vegetables module is here. And here you can see pub mod garden. It means that it tells the compiler to include the code and find its source garden rs, which is source garden rs. Pub mod vegetables. Here pub mod vegetables means that the code inside garden vegetables is included too. That the code is this one. Yeah, pub means public. Okay, grouping related code in modules. Yeah, so it's a way for us to organize the modules. So here one good example is you have front of house and then back of house. Front of house is where customers are. This encompasses where the host sits. Customers, servers take orders and payment, and bartenders make drinks. Back of house is where chefs, cooks work in the kitchen, dishwashers clean up, and managers do administrative work. So you see here, front of house, hosting, add to wait list, sit at the table. So this is what the waiter would usually do. And serving, taking order, serve order, take payment. While as back of house, where is it? Front of house, back of house was not mentioned here. So this one, instead of interpreting this as the tree, I think the other day I made a mistake. I did a tree dot. But in this case, we can treat it as a module tree. So you have the hierarchy. At the root, it's always crate. And underneath that, you have front of house, hosting, where in hosting, you have these functions. In serving, you have these functions. Okay, notice that the entire module tree is rooted under the implicit module name crate. I think yesterday we tried to remove the word crate and it still works. So if you put crate, then that is explicitly defined, but you can also do away with the crate. So looking at this, it's like the directory in a file system also. So you use modules to organize your code, and just like files in a directory, we need a way to find our modules. Path. So there are two types of path, an absolute path and relative path. For relative path, it starts from the current module and uses self, super, or an identifier in the current module. Okay, so I think this is where we can continue. So let's take a look at what is written here. We can read together. So both absolute and relative paths are followed by one or more identifiers separated by double columns. Okay, returning to 7-1, say we want to call add to waitlist function. Okay, add to waitlist is here. This is the same as asking what's the path of the add to waitlist function. Listing 7-3 contains listing 7-1 with some of the modules and functions removed. Okay, we'll show two ways to call add to waitlist function from a new function. Where's the new function? I think this is the new function. Yeah, eat at restaurant. These paths are correct, but there's another problem remaining that will prevent this example from compiling as is. We'll explain why in a bit. The eat at restaurant function is part of our library's great public API. So we mark it with pub keyword. Okay, so in the exposing paths with pub keyword. Okay, so we use pub. We'll go into more detail about pub. Okay, so it says here, let's see, code does not compile. The first time we call add to waitlist, front of house, hosting, add to waitlist. So it looks correct. This is absolute path. Relative path would be front of house, hosting, add to waitlist. But it says here it won't compile. Right. Okay. Second time we call add to waitlist in eat at restaurant. Use a relative path. This is the one. So I think this text here just explained what I mentioned earlier. Choosing whether to use relative or absolute path is a decision. Okay, you'll have to make. Okay. So why it won't compile? Why it won't compile? Hosting add to waitlist is not publicly pre-exported. Okay. So it's not public. Okay, so let's see. So here, as you can see, if it's absolute path, the add to waitlist is actually inside hosting, which is inside front of house. So from child to parent, and then finally here, as we can call that probably as a sibling. And by default, modules are private. So you need to add in pub to make it public. But where do we put pub? Will it be here? Or will it be here? Or will it be here? Let's see. Okay. Okay, we have the correct paths, hosting module, and add to waitlist function, but Rust won't let us use them because it doesn't have access to the private sections. In Rust, all items, functions, methods, structs, enums, modules, and constants are private to the parent modules by default. If you want to make them an item like a function or struct private, you put it in a module. Yeah. So once you put it inside a module, then it's by default private. Okay. Items in parent module can use the private items inside the child module. So if you traverse deeper into the child modules, uh, it won't allow you unless it is explicitly defined as public, because by default it is private. So there's a nice analogy here or metaphor. Think of the privacy rules as being like the back office of a restaurant. What goes on in there is private to the restaurant customers, but office managers can see and do everything in the restaurant they operate. Okay. Rust chose to have the modules system function this way so that inner implementation details is the default. The way you know which parts of the inner code you can change without breaking outer code. However, Rust does give you the option to expose inner parts of the child module's code to the outer ancestor modules by using the pub keyword. Okay, so here, listing 7-5, oh, instead of putting it here, pub is added here. Okay, so there's still an error. Yeah, because add to waitlist is a private function. Yeah. So what happened? Adding the pub keyword in front of mod hosting makes the module public. So it makes the module hosting public, but the add to waitlist is still private. So you need to add in pub and another pub here. And then what happened to front of house? Okay, let's see. Do we still need to add in front of house and define it as pub? In the relative path, the logic is the same as an absolute path, except for the first step. Rather than starting from the crate root, the path starts from front of house. Okay, so the path already starts from front of house. So it means that as siblings, you have access. So I think front of house and the function eat at restaurant, they are at the same level. Yeah, like this. That's the reason why you can also remove crate. And front of house, if we expose mod hosting as public, then you would be able to access it. And then from hosting, if we expose function add to waitlist as public, then you would be able to have access to that function. Okay, so that's the understanding. Okay, so I think that is straightforward, easy to understand. Best practices for packages with binary and library. Okay, main.rs for binary, lib.rs library. Typically, packages with this pattern of containing both a library and binary crate will have just enough code in the binary crate to start an executable that calls code within the library crate. This lets other projects benefit from most of the functionality that the package provides because the library crate's code can be shared. So the binary crate is just to start everything. It's like a bootloader Let's see if that's the correct definition. What is a bootloader? Bootloader, a program that loads an operating system with a computer. Okay, so I think my assumption is wrong. First program to run after power up or reset, probably, mainly because it's the main entry point. Yeah. Or we can just call it as the main entry point of the program itself. Mm, Starting relative paths with super, or okay. This one is something new. We can construct relative paths that begin with the parent module rather than the current module or the create root by using super at the start of the path. This is like starting a file system path within dot syntax. Oh, so it's like when you change directory in a file system, cd dot. Using super allows us to reference an item that we know is in the parent module, which can make rearranging the module tree easier. Okay. When the module is closely related to the parent, but the parent might be moved elsewhere in the module tree someday. Okay. Consider the code listing in 7-8. Okay. Okay, so this models a situation in which a chef fixes an incorrect order. Okay. Back of house, so that's where the chef will cook. Function fix incorrect order defined in the back of house module calls the function. Okay, so it's also calling the function deliver order, which is super. Okay, starting with super. Okay, super deliver order. Deliver order is over here. So does it mean that we are jumping out of back of house and then jumping in to deliver order? Probably. So let's see. The fix incorrect order function is in the back of house. Yes. So we can use super to go into the parent module of back of house. Super to the parent module, which is this scope. Yeah, because here deliver order. Okay. Within this, fix incorrect order is actually inside back of house. So we come out of this and find it. Success. We think the back of house module and the deliver order function are likely to stay. Okay, back of house and deliver order module. Okay. So it means that it will not move anywhere. In the same relationship to each other and get moved together should we decide to reorganize the crates module tree. Okay. Therefore, we use super, so we'll have fewer places to update code in the future if this code gets moved to a different module. Okay, so deliver order is actually within the scope. What if deliver order would be in another submodule? So if you do a super deliver order, then this one will break. So what's the advantage? Let's see. We think the back of house module and the deliver order function, okay, back of house module, deliver order function, are likely to stay in the same relationship to each other and get moved together. Okay, so this is with the assumption that every time we package this code, deliver order will always be together with back of house. Uh, get moved together should we decide to reorganize the crates module tree. Therefore, we use super so we'll have fewer places to update code in the future if this code gets moved to a different module. Who gets moved to a different module? Deliver order. Okay, so if this moves, then we need to update this part. Maybe this one requires a few more scenarios. I think it's hard to visualize, yeah, because either way, I think we still need to change it if this one moves. So it's like if you put in a relative path, if you move this together, then it doesn't matter. We need to really see what is the advantage of this later on. Yeah, with this, I don't know, with this statement alone. Yeah, I think we need to see more realistic examples on where we can actually use super, but as of now, let's take it as it is. Super means coming out of the parent module to access uh, another module or another function. Yeah. Making structs and enums public. Okay, so the only thing new today so far is the super keyword. Okay, we can also use pub to designate structs and enums as public. Okay, because the pub keyword is applicable to all. But there are a few extra details to the usage of pub with structs and enums. Okay, let's see. If we use pub before if we use pub before a struct definition, we make the struct public, but the structs field will still be private. Okay, so the definition will be public, but the structs field will still be private. Okay, so it's like public struct breakfast, but without this pub, toast and seasonal fruit would still be private. So by default, it's also private. Okay. Breakfast, public toast, seasonal fruit string. But the chef decide which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customers can't choose the fruit or even see which fruit they'll get. Okay, so we don't want the customers to change the fruit because it's seasonal. So whatever we have, that's what they get. And in this case, it's going to be private. It's a secret. It's a surprise. Okay, so the implementation of breakfast is here. Summer is also a public function. It's taking in the structured toast, which is okay, so we're borrowing and it returns breakfast. So there's a new breakfast instance here that is returned. Okay, so we're borrowing the value of toast. That's why we have ampersand And okay, so there's a new string here being binded into toast. And then seasonal fruit, peaches. Okay, so it's like summer, we define the menu. Customer gets only peaches. That's it. Cannot select any other fruit. Okay. Then here, eat at the restaurant. We are calling this function back of house. So that's a module here, which is they're in the same level, or they are siblings. Inside that, you have the struct breakfast, and then summer. Summer function is called returns breakfast. So this is public. It means that, yeah, we can call this meal that toast. Okay, so wheat. So this is like, okay, now we are the customer. Okay, so here the customer can specify, okay, wheat for the toast. I'd like toast, please, using wheat. The next line won't compile if we uncomment it. We're not allowed to see or modify the seasonal fruit that comes with the meal. Yeah. Yeah, I think it would be nice if we try this one out. Okay. This is asparagus. Let's go back to main. We can still reuse this, but over here we can include this. Eat at restaurant. So main, from main we can say eat at restaurant. Can I comment this? No, I mean we can comment this out. And let's run. I'd like wheat toast, please. Okay, so it says here if we uncomment this, it will not compile. Mainly because breakfast, seasonal fruit of breakfast is private. Cannot do that. How to fix this? You need to add in pub. Pub. Okay, so there. A crate is added in explicitly. I think in the example in the book, don't need to put in crate. That's fine as well. String blueberries. So if we do a debug of meal, then you'll see it change into blueberries. Oh, I cannot do this, so we'll just borrow it. This. Oops. So breakfast doesn't implement debug. Ah, forgot to put this in. Breakfast. Where is breakfast? Yeah. Here. Try debug. Okay, remove this. Yeah, it should be fine. Now you see seasonal fruit, blueberries. Okay, so if I do another one, of course, this one will complain. So that's the point why we want to borrow it. Blueberries, blueberries. Okay, let's move on. Breakfast, breakfast. Okay. I think that is the explanation of our analysis. So skip that. In contrast, if we make an enum public, okay, in this case, enum appetizer public, all of its variants are then public. We only need the pub before the enum keyword as shown in listing 7-10. So there's a slight difference. If it's struck, you make it public, but the fields are private, not unless if you explicitly define it as public. But for enum, it's all in one. Uh, anything that is enumerated within this enum, it follows that it's going to be public as well. So we just need to take note. Because we made appetizer enum public, we can use soup and salad variants in Eat at Restaurant. And if we have an enum, so if we have a match, then it means that we need to consider all of the items. Is that right? Maybe let's go back here. Enum, yes, yes, correct. Penny, nickel, dime, quarter, then you need to do all of this. That's the cost of using match. Okay, so let's go back. Are we still here? Super, okay. Okay, here. Breakfast and then enum. Okay. Okay, so next page. Bringing paths into scope with the use keyword. Okay. In listing 7-11, okay, we bring crate, front of house, hosting. Here, front of house, hosting. Oh, so we can put it in between module and then the function. Okay. So we only have to specify hosting, add to waitlist to call add to waitlist function in Eat at Restaurant. Okay, so since we use this keyword use create, okay, then all the way to the end, it means hosting, we can just simply use it here, add to waitlist. And add to waitlist, it should be public, okay, so front of house, yeah, public, public, so that's correct. Note that use only creates the shortcut for the particular scope in which use occurs. 7-12, 7-12 moves eat at restaurant function into a new child module named customer, which is then a different scope than the use statement. So the function body won't compile. Let's analyze. Use create front of house hosting. Okay. Then we have mod customer function eat at restaurant hosting. Okay, so it won't compile because hosting is at this scope, but customer is already at the level of front of house, so they are at the same level. Then eat at restaurant. So actually hosting is over here. I think for this to work, then you need to do a super, which was omitted here. So you need to jump out, and then you have hosting, and then you can use hosting add to waitlist. Okay, so without, yeah, we know that, okay, so anyway, I think the explanation is here, yeah, super hosting with the child customer module. Okay, let's try it out just to verify that our assumptions are correct. Restaurant. Maybe let's comment all of this. Yeah, so it will complain. So the solution would be put super colon here. So that should be fine. So super means one layer up. So we are at this layer. Then since use create front of house hosting is here, so anywhere within here means that we can use hosting. So it's like explicitly putting in hosting, colon, add to waitlist, thing like that. Yeah, but of course, this is a module. It means we put it here. So this line and this line, they're the same in terms of path and scope. Yeah, I mean in ways in accessing the function. Okay, let's go back. So the compilation error was fixed. Super. Okay, next, creating idiomatic use paths. What is this? Idiomatic use path. Rather than specifying the use path all the way to the add waitlist function to achieve the same result as in 7-13. The only difference is add to waitlist is added here so that you can call it directly here. 7-11 is the idiomatic way to bring function into scope with use. 7-13. Bringing the function's parent module into scope with a use means we have to specify the parent module when calling the function. Specifying the parent module when calling the function makes it clear that the function isn't locally defined while still minimizing repetition. Minimizing repetition with full path. In code 7-13, the code using 7-13 is unclear to us where at the waitlist is defined. Why it's not clear? On the other hand, when bringing in structs, enums, and other items with use, it's idiomatic to specify the full path. 7-14 shows the idiomatic way to bring the standard library's hash map. Struct into the scope of a binary crate. Hash map. Idiomatic way. So if we clearly specify hash map, then that's the idiomatic way. Function main, so here we can straight away use hash map new. Okay. There's no strong reason behind this idiom. It's just the convention that has emerged. And folks have gotten to used to reading and writing Rust code this way. The exception to this idiom is if we're bringing in two items with the same name into scope, we use statements because Rust doesn't allow that. If we're bringing two items with the same name. 7-15 shows how to bring two result types into scope that have the same name but different parent modules, and how to refer to them. Okay, so std, fmt, stdio. So I think both of these will have result. Yeah, result. Bringing in two types with the same name into the same scope requires using their parent modules. So it's to differentiate result from FMT and result from IO. Or I think you can do FMT : result here and IO : result. Then you can remove this one. Yeah, so we can try that one just to test it out. Mismatch because there's a snippet probably. So it can return empty. Oops. Happened. Is that correct? Okay. So if we do something like this, then we can remove FMT. Yeah, because we're quite sure that this result is referring to this one. This one is referring to IO. So if we remove IO here, will happen? Will it be okay? I think it will complain. Yeah, it will complain because now it doesn't know which result are we using. So to fix that, we need to put in result here. So yeah, result T. So I think T is the no fixes available. Oh, we cannot do something like this. I do it like this. How to fix it? It's result T. Result T error. Uh, T error. Yes. No. Quick fix. IO error. We have unnecessarily complicated things. I remove this and result. Okay. Can I put in result this? Oops. This with parentheses. Some part. Yes, it worked. Okay. Maybe that's one of the advantages of having this as IO colon here. This one will return result with, what is this parenthesis? We don't understand it yet, but maybe in the later chapters, maybe we'll know what this means. Yeah. Okay, anyway, what we have discovered here is not to make it ambiguous. Say we are referring to result as part of the module empty, then we do something like this. Then IO here, something like this, or vice versa. You can interchange. Interchange in the sense that, yeah, anyway, we can skip it for now because I was having difficulty how to properly put in the module for result. Sorry for that. Okay, let's continue. Maybe we'll discover something later on how to properly do that. Oh, oh, I can do something like this. IO result as IO result. Ah, interesting. Let's try this. Copy result as oh, is that correct? IO colon 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 result as IO result. Here, of course, it will complain. So This one you can remove it as IO result. Hmm. Yeah. Okay, so there's another keyword as IO result. What does it mean? In the second use statement, we chose the new name IO result for std IO result type, which won't conflict with the result from std FFT. And we've also brought into scope in listing 7-15 and listing 7-16 are considered idiomatic, so the choice is up to you. Okay, so we don't know yet how this is possible, maybe in the later chapters. Yeah. Okay, re-exporting names with pub use. Okay, when we bring a name into a scope with the use keyword, the name is private to the scope into which we imported it. To enable code outside that scope to refer to that name as if it had been defined in that scope, we can combine pub and use. This technique is called re-exporting because we're bringing an item into scope but also making that item available for others to bring into their scope. Okay, so pub and use. Okay, so if we are just using use, so we're bringing hosting into the scope. But now if we have pub, can combine to enable code outside that scope. Okay, meaning outside the scope, to enable outside the scope. So meaning, I think hosting would be available from outside of this scope. Re-exporting, yeah. Hmm. So that is possible. Re-exporting, okay. Before this change, external code will have to call add to waitlist function by using restaurant. Where's restaurant? Yeah, so I think the entire scope is restaurant. Front of house hosting at waitlist, which also would have required the front of house module to be marked as pub. Yeah, meaning we need to put pub here if we need to call it at restaurant level. Now that this pub use has re-exported the hosting module from the root module, external code can use the path. Ah, okay, because of this. So restaurant, instead of using front of house and then hosting, so there's a shortcut, so hosting can be used directly. So now it's shorter. Restaurant hosting at the waitlist instead. I think if we do it like this, then it's even more complicated to traverse the modules. I don't know, maybe there's some use case where this could be an advantage and easier to maintain, but we don't know yet. Re-exporting is useful when the internal structure of your code is different from how programmers calling your code would think about the domain. Okay. Okay. For example, in this restaurant metaphor, the people running the restaurant think about front front of house and back of house, but customers visiting a restaurant probably won't think about parts of the restaurant in those terms. Yeah. Okay. So it's like if you think of this restaurant. Okay, I'm the customer. Go to a restaurant and I want to be added to the wait list. So whether you have front of house or back of house, it doesn't matter. To me, the important thing is I want to be added to the wait list. Maybe that's the idea here. Doing so makes our library well organized for programmers working in the library and programmers calling the library. Okay. Using external packages. Okay, so I think this one, let's see. Uh, let's take a quick break, maybe few minutes, maybe 5 minutes. Let's come back. All right, so welcome back. Where were we? Using external packages. Okay, so to use external packages, so we have used rand in the early chapters, chapter 2. So inside cargo.toml, we had rand 0.8.5. Adding rand as a dependency in cargo.toml tells cargo to download the rand package and any dependencies from crates.io and make rand available to our project. Okay, then bring rand definitions into the scope of our package. We add use. Okay, so here use rand RNG. Recall that in generating a random number in chapter 2, we brought RNG trait into scope and called the rand thread underscore RNG function. Okay, I think that was in day 1 or yeah, most likely in day 1. So we had rand thread underscore RNG. So this is a function. Then inside this function, you have gen range. I'm still clueless what equals here. Oh, wait. So if it's 1 to until 100, I think that's what it means. Equal is inclusive of 100. Okay, but the point here is how we use external packages. So rand, and we use rand and RNG, so that in RNG we can use rand and thread that underscore RNG function. Okay, so members of the Rust community have made many packages available at crates.io. Pulling any of them into your package involves the same steps. Okay. So here, note that the standard std library is also a crate that's external to our package. Because the standard library is shipped with Rust language, we don't need to change cargo.toml to include standard library. Okay, so it's already shipped. It's included. But we need to refer to it when with the use to bring items from there into our package scope. For example, with hashmap, we would use this line. Yeah, I think anything with standard library, we don't need to add it into cargo.toml like this. But we still need to make use of the use keyword. This is an absolute path starting with std, the name of the standard library crate. Okay. Using nested paths to clean up large use lists. Okay, so nested. For example, these two use statements we had in the guessing game. Bring items from std into scope. Okay, std cmp, ordering std io. Okay, so we can simplify them. Or we can use nested paths to bring same items into scope in one line. Okay. We do this by specifying the common part of the path, followed by 2 colons. Okay, common part, this one and this one. And then cmp colon ordering, comma, io. Okay. We can do something like that. So it's just a way to simplify this to one line. I think having curly brackets for uh, for somebody who is first time learning the program, I think it's quite confusing. This one is more straightforward. Like if you say use uh, crates or library, although it's line by line, but it's easy to understand as compared to now you're introducing a new convention. Yeah, but definitely this one will keep it in one line, or I don't know. So it's still a preference, or whether if somebody says that, oh, this is the best practice, then you should follow it. Okay. It's just a way to give us options, probably. In bigger programs, bringing many items into scope from the same crate or module using nested paths can reduce the number of separate use statements. Yeah, that's correct. We can use a nested path at any level in a path, which is useful when combining two use statements that share a subpath. For example, okay, use statements. Okay, so how do we do this without looking at the text below? So std colon colon io comma no std colon colon io, then curly brace right. Okay, let's see. Oh, can put in self. Self would mean this one, and then right. So that's why I was a bit hesitant to just include right, and then how do we consider this? Okay, so there's a way. You can use self. Do they have wildcards as well? Let's see. Like stdio colon colon asterisk. I don't know if it's there. Oh yeah. So I spoke too soon. There is glob operator. So yeah, anything under stdio, then I can put asterisk, just like this one. Std collections, then asterisk. Okay. The glob operator is often used when testing to bring everything under test into tests. Okay, we'll talk about that in how to write tests in chapter 11. It's not that far. Okay, so these are, I would say, essentials of writing proper program or application to have tests, test cases, have it automated. Okay. Okay, the glob operator is also sometimes used as part of the prelude pattern. Prelude, okay. I don't understand this. Maybe it will be mentioned somewhere here later. See the standard library documentation for more information on that pattern. Okay, let's avoid the temptation into going down into the rabbit hole. Let's stick to the program. To I don't know how many days this will take. Yeah, but let's see. Let's move on. Separating modules into different files. So far, all the examples in this chapter define multiple modules in one file. When modules get large, you might want to move their definitions to a separate file to make the code easier to navigate. For example, let's start from the code listing in 7-17. Okay, let's assume we remember that we had that multiple restaurant modules. We'll extract modules into files instead of having all the modules defined in the crate root file. In this case, the crate root file is, okay, So lib.rs. So this procedure also works with binary crates. So crate root file is main.rs. First, we'll extract the front of house module to its own file, removing the code inside the curly brackets for the front of house module, leaving only the mod front of house declaration so that source librs contains the code showed in listing 7-21. Note that this won't compile until we create front of house.rs. Yeah, I think somehow we did something similar. Let's take a look at the previous one. Okay, main rs, where we had mod garden. Mod garden is here. Where we had mod vegetable. Yeah. Okay. Front of house rs. Yeah. So it's similar to the vegetable garden. Okay. So is there anything new here? Yeah. Okay. We'll extract hosting module into its own file. So that will be hosting module house hosting and then front of house hosting.rs. Yeah, so that is similar to main. You have garden vegetable. Inside garden you have vegetable.rs. Okay, alternate file paths. Okay, this one we have covered, or you use this naming convention. Hosting, yeah. If you use both styles for the same module, you get a compile error. Okay, so I think if you have both hosting rs and mod.rs, using a mix of both style for the in the same project is allowed, but might be confusing for people navigating your project. Yeah. The main downside of the style that uses files named mod.rs is that your project can end up with many files named mod.rs. Yeah, right. I think it's better to keep it like this, which can get confusing when you have them open in your editor. Yes. Yes, eventually when you open, then that will be mod.rs here and another mod.rs here and another mod.rs. Correct. So this way is better. Oh, no wonder. This is the older style. So it could be in the early days of Rust implementation. They were doing this. Finally, change it to this one. Okay. Summary. Oh, now we're at the end. Rust lets you split a package into multiple crates. Okay, use statements, adding pub keyword. In the next chapter, we'll look at some collection data structures in the standard library that you can use in your neatly organized code. Okay, let's see. Common collections. How long is this? Oh, I think we can save this for another day. It would be interesting to try and see maybe crate.io. Let's take a look. Crate.io. CrateDB, your unified data layer for analytics, search, and AI. Start. Decline. Close this. Search. Maybe keyboard. Let's see if there's something here to uh, like a library that will read key inputs, maybe keyboard or key. Oh, keyboard. Let's see. Great. Come on. Oh, this is. Am I in the right page? This one doesn't look like crate.io. That. Ah, crates.io. Mistake. Yeah, yeah. This is more like it. I think last time we were looking for rand here. Rand. Yes. Okay, so let's try to understand what's in here. Uh, where can we find the documentation? Expressions, dependencies, readme. Okay, this is the readme. Rust random GitHub IO book. Okay, or maybe this one document. Okay, this one is the documentation. Okay, so the crate is rand. Start. Use rand. So in cargo.toml, that would be rand equals 0.999.1. As the dependency, we can put it here. Okay. Then, okay, here's a quick start. So we can use anything under rand. Okay, the preload import enables methods we use below specifically. Okay. I think later on we'll try to understand what this means, but let's make an assumption that everything under rand is included. So rand RNG. Okay. So this is I think it's like a constructor perhaps. So it will return a value and bind it to a mutable variable g. And print line random is a function. Car. Okay. Okay. So this is try printing a random Unicode code point. Okay. Says here probably a bad idea. Try printing a random alphanumeric value instead. Sample. This could be a function rand distr, maybe this distribution. I don't know. Alphanumeric. Alphanumeric looks like an enum. Ascar. Hmm. How can we verify this? Okay, distr is this one. It's a module inside rand, and then alphanumeric is a simple distribution to sample letters and numbers of card type. Okay, so let's take a look what's inside alphanumeric. Okay, I was wrong. Alphanumeric is a struct. Okay, uh, if it's a struct, then how do we uh, trait implementation. So to understand this, then we need to know what is a trait, auto trait, blanket, modules. Okay, you have modules inside this perhaps. Alphanumeric is a struct. Okay, alphanumeric is a struct. Is a struct. Uh, and how do we know what are the fields within this struct? Maybe it's the trait? No, no. There are implementations. Okay, so for the struct alphanumeric, there's an implementation called clone, maybe. Okay, then clone will have um, what is this? Constructor. Clone from. Oh, you cannot have clone, and then different parameters to change it to something like this. Okay. I think at this point it's still quite difficult to understand the documentation of a module. So let's resist the temptation for now, and I think we'll get more clarity once we dig deeper into common collections, and then we'll see, okay, at least here there will be some explanation. Yeah, I think T, we have encountered this before. New, so new is this one will create, yeah, a new empty vector. Okay, so to create a new empty vector, then we call new. Okay, so we'll leave that for the next day. Hopefully we could cover everything here for collections. So vectors, vectors. Slice strings are revisited again, okay. Oh, UTF-8. Storing keys with associated values in hashmap. Yeah, hashmap is very useful, I would say. Hashmap, hashmap object, hash table, dictionary. Okay, this one is very important. And error handling. Error handling should be quite short. We do error handling, cover all errors. Okay. To panic or not to panic? Parse expect. Okay. Interesting. Okay, so let me end here. Thank you so much for accompanying me in learning how to program in Rust, day 8. So now we have a more clearer understanding on how we can organize our code using modules, grades, the use keyword, how to expose it as public since everything is private. Yeah, so those things are quite important. And yeah, so let's continue to push forward and learn more things about Rust. Thank you so much. See you in the next video.